day, students. Welcome to session 6 of Unit 2 of PCK in Chemistry. This session is about preparation of solution and is the third aspect. We have looked at the first aspect, second, and this is the third. Let's look at our objectives for the session. You should be able to describe how to prepare standard alkali solutions. We have already looked at standard acid solutions in the 2. You'll be able to describe how to prepare standard salt solution. So we kick this off with the first objective, which is the preparation of standard alkali solutions, and we are looking at it with a question or a task, which is to describe how you would prepare a 250 cubic centimeters of 0.2 molar or mole per dm cubed sodium triisocarbonate 4 solution for a practical lesson. In other words, you are to prepare a solution, but that solution should have a volume of 250 centimeters cubed and a concentration of 0.2 mole per dm cubed. We have the relative atomic masses given here. Now, what you have to ask yourself is, with the chemical from which I'm going to prepare the solution, what is the physical state? Is it in a liquid form or it is in a solid form? Usually, if it is in a liquid form, then it is convenient to measure volume. So you'll be working for volume. If it is in a solid form, then it is convenient to weigh mass or measure mass. So you'll be calculating for which mass to weigh. The sodium triisocarbonate 4 comes in solid form, so we have to weigh mass. So what we have to calculate for is the mass that we are going to weigh for our solution. And with that, we need the molar mass of the sodium carbonate. So given that we have the relative atomic masses, we do our substitution in the relation for molar mass. Then we find the molar mass, in this case 106 grams per mole. That is not the mass we are going to weigh, that's the mass in 1 mole. So we have the concentration and then we have the volume that we are going to prepare. So we have to use this in addition with the molar mass to find the mass to weigh. Now, from the relation concentration is equal to mass over molar mass times volume, we make mass the subject, and that gives us mass being equal to concentration times volume times relative molecular mass, or the molar mass. We know the value, so we do our substitution, and that gives us 5.3 grams. So in the lab, you are going to weigh 5.3 grams. Let's look at, after weighing or after knowing the mass to weigh, what's next? One is that you weigh that calculated mass of the sodium carbonate on a watch glass, and then you transfer it into a beaker. Here we are not transferring it straight away into the volumetric flask because this is solid, it can be hard, and we have to dissolve it before. The volumetric flask is such a way that you cannot use a stirring rod to dissolve something in it. So it is very convenient to first dissolve it. That's why we are transferring into a beaker. So you transfer into a beaker, and then you wash the particles of the sodium carbonate remaining on the watch glass with the distilled water into the beaker. Remember, here too we have a particular concentration that we are preparing. So if we make any mistake, if we leave any of the particles of the sodium carbonate behind, we are not going to get that very concentration. That's why we have to rinse the watch glass and then add to the beaker. Now, doing this, then we add small amount of water to the beaker and then we stir. Why are we stirring? We are stirring so that we will have the sodium carbonate dissolve. So we dissolve it first in the beaker and then we transfer the solution in the beaker into a volumetric flask. In the selection of volumetric flask, you should be careful about which volume you are preparing. For instance, if you are preparing 250 cubic centimeters, don't go and select a 500 centimeters cubed volumetric flask. Select 250 cubic centimeters volumetric flask. So transfer the contents of the beaker into the volumetric flask, and then you may rinse the beaker again into the volumetric flask. So you don't select a big beaker that you use plenty water to dissolve. Then by the time you even transfer into a volumetric flask, you already have some remaining in the beaker. In that case, you have spoiled the whole thing. So at least a sizable beaker with a small amount of water. So you rinse, then you add to it. After that, then you can add more distilled water until the solution or the volume of the solution reaches the 250th mark or the mark on the neck of the volumetric flask. When you are done with this final step, you may shake it a bit and then you cover it for the use in the lab or for whatever purpose you intended. Another example is for us to describe how we would prepare 250 cm cubed of 0.05 sodium chloride. This is ordinary salt. So we are preparing a salt solution, but with a volume of 250 and then concentration of 0.005. The salt comes in solid form, so we have to look for mass. We have to calculate to get the mass that we are going to weigh. We have the relative atomic masses, and so we kickstart with the molar mass, which is 58.5. Then, with the relation for mass, concentration, molar mass, and volume, we do our substitution to get the mass to weigh, which is 0.731 grams. So we go to the weighing balance, and we weigh just more mass as usual on a watch glass, and then after that we transfer it into a beaker. Then we wash the watch glass into the beaker with distilled water. After that we add distilled water. It's just like the steps that we followed in the first instance. So we add water to the content of the beaker, then we stir with a stirring rod for the solution to take place. After that, then we transfer the resulting solution into the right volumetric flask. In this case, since we are preparing 250, select 250. So we transfer into 250 volumetric flask. Then we add more distilled water to the solution until its meniscus reaches the 250 volumetric, the mark, 250 mark of the volumetric flask. You need to take note of this. As you are adding distilled water to the content of the volumetric flask, if it passes the mark on the volumetric flask, please don't take some of the volume away for it to go back. You have compromised on the concentration. Okay, you may end up having lower concentration than the actual concentration you are preparing, so you have to start the whole thing again. So when you are adding, you need to be extra careful such that you get accurate measurements, because if it passes, you have lowered the concentration. You are not getting the actual concentration. And if it doesn't reach 2, you have a higher concentration than what you want. So be very accurate in these measurements. So my good friends, we are ending this session and we are ending with a task. Please go and then do it. You are to describe how you will prepare 2,000 cubic centimeters of concentration 0.5 molar sodium triisoocarbon 4 solution for a practical lesson. My name is Robert Chumesi Kumar, and Thank you very much.